Hello, welcome back. So we're now going to start with applications of integration. That's our chapter 7 material. Okay, so 7.1 specifically, it's actually not really anything new, but it's just area between curves. So it's kind of nice. There isn't really nothing crazy new, but let's look at a problem that sort of illustrates a lot of what I want to sort of get across in this section. Okay, so let's find the area bounded by the curves y equals sine of x and y equals cosine of x from 0 to 2 pi. Okay, so one of the things that I'm really going to insist on the exams is that you do graph these things. Okay, so if you don't graph it, you're going to be marked off. Just understand that. I say it every semester, and still people don't graph things. I don't get it. Well, I do, but I'm trying to break you out of out of what it is that makes you not graph it. Okay, so you got to get better at graphing things. Okay, so y equals sine of x. We actually know what that looks like pretty well. So I'm going to graph this one in blue. There's y equals sine of x, and y equals cosine of x I'm going to graph in orange. Okay, so now, what is the region bounded by the curves? Well, the region bounded by the curves is actually this region. Okay. All right, let's actually do a little bit more. Let me actually go 0 to 4 pi. Sorry. Okay, because I want to show a little bit something else. So this would keep going, right? And sign would, of course, repeat itself. As would cosine. Okay, so now the thing is we're actually going to have 3 different areas. It actually doesn't even cost us any more work, so that's why I decided to go ahead and extend it. Okay. Oh. All right. So let's go ahead. We are going to write down what the integrals are, though. Okay. So here, well, we know when sine and cosine of x are equal. They're equal at pi over 4, 5 pi over 4, and then it's going to be again, oh, let's do it here. This is pi over 4. That's where they're equal. This is 5 pi over 4. This is going to be basically like pi over 4 again. That's 9 pi over 4. There, that's going to be what, like 5 pi over 4 plus 2 pi is going to be 13 pi over 4. Okay? So, another thing is we can pretty much see that they're going to be the same. All these 3 areas are going to be the same. Okay? but I want to write down the integral. Here, this is the integral from pi over 4 to 5 pi over 4, and it's going to be which one is above? Sine of x minus cosine of x. Plus, now from here, remember this is region bounded by, so that means this isn't bounded and this isn't bounded. Okay. Plus, here we're going to go from 5 pi over 4 to 9 pi over 4. What's the upper one? Cosine. Plus, again, the integral from 9 pi over 4 to 13 pi over 4. That's going to be, again, sine x minus cosine x. Okay. So what I want you guys to, or I want you all to realize is that we're taking, always, we're looking for points of intersection, okay, we're looking for upper minus lower, okay, we're taking the upper function minus the lower function, so we should always get a positive value. Okay, and this one would be 3 integral pi over 4, 5 pi over 4, sine x minus cosine x dx, and I will assume we all know how to integrate that. Okay? All right, I will see you in the next video. We'll start doing some more problems. I'm just going to be setting up the integrals unless it's a really hard integral. Okay? All right, see you there.